Welcome everyone to this hopefully short encore to the second lecture. In this part of the lecture we want to deal with plot customization, so we don't want to necessarily change the what we plot, but we want to change how it appears. So I don't want to say the color, maybe like the font of a text or the label of an axis. These are the kind of things we want to change here. And this is a lot of work with details in the plot, but this can sometimes make your improve your plot by a lot if you just tweak a few things and change the theme. And so this is what we are going to learn here. But because it works with the details of a plot, it also feels tedious a lot of times to change these small things, and sometimes it feels like super complicated to change something, and this is something which you only get used to by repeatedly trying a lot. So here I don't want to go into that much detail why some things are programmed the way they are, but more I want to give you the general gist of what screws you can change or turn to get the results you want. In any case, let's just get started and then we'll see what we're able to accomplish. So here you see a box plot, or more appropriately 5 box plots we plotted earlier, and we arranged the box plots so that their medians are in ascending order, but we used the function reorder function in here, or the factor reorder function here in our mapping, and so our label here in the legend is also unnecessarily long. And of course, if you look at the figure like that, you will see that it feels not finished, and this is why you should improve this plot by simply changing the labels a bit. Same here, the live exp, if you want to publish this figure somewhere, you will need to probably label the y-axis not by the variable name, but actually what it is we're looking at. And all of these things are controlled by the labs function. So into the labs function you can basically throw in all labels you want to change. So if you want to change the labels of the y-axis, use say y is equal to and then some string. In this case it should be life expectancy, because this is what life exp stands for. Then we want to change the color legend. So here we have a long legend for the color, so we simply write color is equal to, and then this relates to the continent, so we'll just write continent. Also, what you can do with ggplots is you can add titles and subtitles. Sometimes that's nice, so you can describe what it is that you want to that you're actually plotting there, and sometimes you can even add a subtitle into it to explain in a sentence your main finding. And here it would be that vast differences between continents emerge, and this would be then our final plot. And yeah, that's basically it. Here we change the labels, and sometimes what was the most pressing issue was that our legend had like a huge label, but sometimes, as we have seen for instance in this plot, we don't actually need a legend at all, because we have more or less the labels of the continents in the facets here, so we don't need to use the color code here because we can see it from the facets. So there it helps to get rid of the facet altogether, and you control this by a different layer. So this is not the label layer but the theme layer that controls that. Actually the theme layer controls a lot. You can see here I have the documentation of the theme command open, and all of these arguments of the function are possible things you can change, and we'll go through a couple of those, but in this case you want to deal with the legend, so let's look at only the legend. And then we'll see, okay, legend position is something we might want to change. Maybe we want to have the legend at the bottom. In this case we want to have it nowhere. So in this case, we look at legend position. Here's the explanation, and then the positions, the possible values are none, left, right, bottom, top. In this case, we want to use none. So we write simply legend position is equal to none. And this way we got rid of the legend. Just for experiment's sake, if we were to put it at the bottom, it would look like this. But again, here we don't really need it, so let's get rid of it. Similarly, you sometimes might have a use more than one aesthetic, and you want to get rid of a legend for one aesthetic but not the other. If you use theme legend position is equal to none, you will get rid of all legends. So for instance, if you map the size to a variable and the color to a variable in, for instance, a scatter plot, then you will get rid of all legends. So let's look at a small example here. Basically, this is the plot we looked at earlier, only that so the scatter plot with the colors with respect to the continents, and now I changed the sizes of the points with respect to the population size of a country. And here I don't really want to show the population. And again, as I said, if I use theme position, legend position, of course, if I set this to none, then all of the legends will disappear, but I still need the information about the color, but not so much maybe about the size. Point is just, okay, if the bubble is bigger, then the size of the country is bigger. I don't care about the specific number. So theme won't help us here, but what will help us is the guides function. There you can say size is equal to none. Alright, if you look into the guide functions, you will find a few examples. So for instance, the guide function is to set something like, okay, you can have a legend for something, for instance, or if you want to change something to a color bar, you can say, okay, the guide function now displays the color bar instead of, I don't know, something else, like a regular categorical type. Let's simply see what happens if we set this to color bar. And we should get a continuous scale, so that probably won't help us. In any case, just more or less you can just stick to this to guides function if you only want to get rid of one single legend. In the other case, just ignore the guides function. Okay, so if I throw this all together for our earlier plot, then we could have something like this. So what I did was, look at the GDP per capita with respect to the life expectancy with respect to GDP per capita again, and linked the sizes of the points to the population size. I still have the legend that I left here, but I moved it to the bottom, and then I added some titles that came to my mind. So this is basically combining a few things. Again, this is just by adding the respective layers on top of each other until you have changed all the things that you want to change. Okay, now let's talk about, we were talking about labeling in general, so we were dealing with the labels overall, but sometimes you want to change the labels of specific points. Maybe you want to have this big bubble, green bubble here displayed, or the country name displayed. And so you would need to label that specific point. And there is a way to, so that we can, there's a way to achieve that, but it is more or less a new geom that we add. It's not like a labs function or guide function, it's a whole new level of geometric objects, because we're adding texts, another layer of texts basically. So let me just So here we plotted the life expectancies in 2007. So now we want to just have a few selected countries labeled there. And let's just take the selected countries we were looking at earlier. So this was the table we looked at when we were only trying to look at 5 countries. And of course this still has different years. We only want to look at the year 2007 so that it is in alignment with this data set. So we filter it again and we see these 5 data sets will be labeled. So let's just save this. 2007, and then we'll label these. Okay, so our initial plot will look like this. We had that earlier, it's just copy and paste it in here. And I got rid of the titles again so that we can focus on what we really want to change. So the labels here. And we want to add a layer of text. But as I said, we won't want to label all of the countries. We only want to label the selected countries that we have here. And the goal, or not the goal here, the thing we have to do so that it works is that we have to change the data only for this specific layer. So we already know that within this layered grammar of graphics, each layer contains the data. And usually you only give the data in the first initial layer and then the rest is inherited. But here is a nice example for when you want to override this inheritance, because in the GM text you only want to label the very specific countries. So this is why you need to adjust the data here. So data will be the selected countries, and then the mapping, we'll have to change it to, we have to declare it by a label. And this will be taken from country. So the X and Y coordinate of that label, so of that text, will still be inherited from this initial layer, because here we have the X and Y. But what we also want is that the new additional aesthetic label that is specific to GM text, this one is declared in this last layer. And if we do that, we'll see that, okay, we have the countries labeled now. It doesn't look very nice for now. We will deal with this, but what I want to deal with first is our legend here. Again, we have trouble with our legend because not only is there a point in here, it's kind of hard to see, maybe if I make it enlarge it a bit, you will see that there is an A in here because that's the legend symbol for the GM text layer, and there's a point in there which is the legend symbol for GM point, and both of them is mixed, and it's nonsense. It doesn't make sense to mix it like that. So what you want to do here is to get rid of the legend, and you want to get rid of the legend for, not for an aesthetic, but for this whole layer. So this is why you can just simply change the argument of show legend to false. This will then ignore the legend labels for this layer, and this is why you will get rid of the A's here. Okay, so instead of GM text, we could also use GM label, because this puts a box around the labels to make it hopefully more legible. So let's see. Okay, this looks better. At least we can sort of read the text, at least in some instances, but we still have a lot of overplotting going on here. We have we can't see the complete label, but also the label itself, they block the view to a lot of points. And we can use a different layer. We can use the GM label repel layer from the GG repel package, which does exactly the same thing, but it tries to move the labels out of the way. So here all I changed was this part here. So now instead of GM label, I'm using GM label repel from the GG repel package. And now it looks a bit better. And if we want to tweak it even more, then we could use the mappings box and point paddings, which you will get to play around in the exercises. Here I will just show you what it can do. It can move the labels even further and connect the labels to the respective points via a straight line, which can help so that you can read both or see both the points and the label properly. Okay, so this is everything I want to talk about, say about labels. So let's talk about themes. Themes are a great way to change the whole appearance of your plot. So you don't necessarily need to tweak every little thing, but you can just add a theme layer, and so there are a lot of kind of default themes that change the appearance quite nicely, but you don't have to change the details yourself. For instance, let's just take the previous plot and we add a theme. As you can see, there are a couple of themes that we can choose from here. Let's just take the theme black and white, which is a minimalistic theme which gets rid of the gray background and changes. Yeah, it's more or less the gray background that changes. But we can also, if you look at the documentation of theme black and white, then you can see there even more. For instance, theme dark. Let's look at it. I don't know how it looks. Interesting. In any case, just pick whatever you like most. And yeah, this is an easy way basically to change the whole appearance of your plot. There are even more already predefined themes. The package for that is, I think, GG themes. Let me check. Maybe it has some other name. I will. In any case, if you don't want to use the ggplot2's standard themes, you can just look at different packages and they will come with other themes you can simply add to it. But of course you can always change specific parts yourself. So this is where the theme functions comes into play, as I already said. Again, with the theme you can change all of those things here. And the general idea is that, for instance, if you want to change let's just change the axis title here. If you want to change the axis title, so you want to change a specific element of the plot, then you will have to use an element function that corresponds to that element you want to change. So the title is a text, so you will need the element text function to change it. And there you can simply, if you look at it, you can change a lot of things. Where is the element text? So for instance, size, you can increase the text size, or you can make with face, you can make it bold. So let's just make it a little bit larger and make it bold. All right, so as you see, this one, the labels became bold now and larger. So exactly what we specified. And it's always the same thing. You want to change a specific part, you can find in the theme function. So let's say the panel background. So the panel is this part here, what is gray now, and we want to change the background color. So again, we need to use the theme function, and then we need to match the element to the corresponding element function. In this case, it's element rectangular because, well, we need to change that rectangle. and we need to change its fill argument to a color we want, say pink. And there you go, you have now a pink panel background. If you fancy that, you can stick to it, or you can change it to whatever. The point is, you can change basically every small detail in here to your desire. The main obstacle to change that is actually to know what specific element do I need to change to get what I want, and then what element function do I need to combine it with. And of course, this is not something you need to randomly try. You can, if you look into the lecture notes, you will see in the theme section, I have put a link to the ggplot2 book, to chapter 18.3 and 18.4 specifically. And if you open that, then you basically get an overview of what changes what, and you can immediately see, how did the plot change when these lines were executed, and so on. And if you want to change something specifically, you can just look through it and see, okay, where did that part change that I wanted to change? Okay, maybe I wanted to get rid of the grid. Okay, let's see what did they do here to get rid of the grid. This is kind of the way you can work yourself through it. In my opinion, it doesn't make a lot of sense to read it just all the way through from top to bottom. Just pick out a few things you want to change, and then simply try it and see how you can tweak yourself and make it somewhat more interactive. Actually, in the exercises, you will be forced to do it, because I will give you the assignment of taking a figure that is already created with ggplot and then try to make it the ugliest figure you can possibly make it out to be. So what I mean is really try not to improve it, but try to make it ridiculous. Change the colors, change the text, make it bold, get rid of the grid lines, whatever you fancy, change the numbers of the or the format of the numbers, or the alignment of them, maybe put them on their head, whatever you can think of. The point is, don't try to improve it, so you don't need to feel like what you're trying is you need to get it right the first time. Just the point of it is not get it right, so just simply try it out and make it as ugly as possible. That's the kind of idea. So this will be the exercises where you can play with all those commands here, which are the same commands, of course, as these here. And then, just go as long as you like, and make it as ugly as possible. All right. So that's all, everything to themes. Okay, I'm already at 23 minutes. I will try to make it brief, give a brief introduction to scales. So as we already know, the mapping describes what variables in my data set correspond to the visual attributes of my figure. So here I know, okay, I mapped the x coordinates to GDP, the y coordinates to life expectancies, and the color to continent. So as we know, the mapping determines the visual attributes of the figure. But we can, in the background, there is also scales at work. So whenever we plot something like this here, so if we map, for instance, the x aesthetic to some variable, then we also simultaneously use the scale that is responsible for the x aesthetic. That's sort of how it goes. So every aesthetic has a scales layer. So if we would add plot something like this with the x, y, color, and size aesthetic used, then we would in the background also have the appropriate scales plotted to it. And the scale functions, they come in two types. Basically, it's always scale, underbar, then the name of the aesthetic it corresponds to, and then the type of the scale. So in these cases, for instance, x, y, and size are continuous variables, so their type is continuous. Color obviously is discrete as it's categorical, and this is why the name there is discrete, why its type is discrete. And through these functions, we can change how we map the data to the visual properties. So for instance, with the scale x functions, we can transform it. That's like a typical thing to do. So instead of plotting it exactly the way it is, we can transform it. So for instance, we can do a log transform, so it uses the log10 function to transform the point. So as you can see, it changed the axis, the x-axis changed now because we transformed them using a log transform. Similarly, we could also use something else. We could also use the square root. And here again, you saw that the x-axis changed. All right, but now that we have transformed it, you may feel like the grid lines are annoying, and the grid lines are basically the breaks of the scales. So we need to adjust the breaks of the scales. So for instance, if we want to have the grid lines at specific values, we simply set them to that, and therefore the x-axis changed. So we only have the breaks here in that part. Okay, so again we changed the x-axis here. Similarly, we can change the y-axis here, and the common thing you may want to do is to express your y-axis not as the numeric variable that you put into, that you get from the data. So here the life expectancy is something between 40 and 80. So these are the numeric variables. But again, maybe you want to transform it, or you simply want to label them differently. And the way you can do it is through the scale function and then adjusting the labels argument. And the labels argument basically either takes a vector of the labels you want to give. Then you would in this case need to give 6 labels so that it corresponds to so the amount of labels you want to change corresponds to what is actually plotted here. But this sometimes can get tedious as the amount of labels that are plotted change. So this is why often you simply give a function that takes labels and gives labels back. For instance, if you want to, here it doesn't make any sense to convert it to %, but in this case, let's just do it anyway. So here we can use from the scales package the % function. And you have to be careful, as you saw just now, our studio tried to autocomplete the % function and immediately gave these 2 parentheses. And if I try to execute it now, it will say, well, the scales function has an argument missing, because of course I didn't put anything here and there are no defaults there. So we didn't actually try to pass the function to the labels. What we did was we tried to execute the function and the result of it, try to pass it to the labels. So here you have to be careful. Simply write out the name of the function and without the parentheses. And if you do it, then it transformed or relabeled the already existing the data that we have here. All right. Another thing we can change, we have more scales that we can use here, is to change the scale with the color scale. So these are the default colors here, and at some point you will probably get annoyed by the same standard colors. You want to change them. And an easy way to do it, okay, we'll just take this. We will get rid of the stuff we changed earlier, so we can focus on the color exclusively. And then we want to, this is how it will look like if we don't change anything. That's basically out of the box. And now we want to apply a different color set to it. Again, we still want to use other colors. But we don't want to assign the colors our own. We still want to let R do the handling of that, or ggplot let the handling of this. So we still need to let the scale function run its course, but we can still say, okay, the choices of your colors, don't take it from this one set, take it from the other color set, and then I maybe am satisfied with the other colors we used. So a different color set is given in the Brewer package, is given by Brewer. That's the name of the color setting, and immediately we saw that, okay, we didn't actually change a lot, but the colors changed, and we can still adjust even more. We can, within this Brewer scheme, there are different color palettes, so we can simply change it to, I don't know, set 1 in this case. This is one name of the color palette, or dark 2 is one. And this way we don't actually have to do the color choosing on our own, but we can still choose different colors if we're sick of the default colors. And if you want to see what colors there are available, you can simply execute from the rcolor Brewer package the display Brewer all function, which will give you the corresponding colors. So here we see, for instance, set 1 were these colors. What else did I use? Dark 2 were these colors, and so on, and there you can choose whatever color you fancy. Okay, so one last thing with respect to the color scales, and then we're done, is that you can, of course, change the color scale if it's even if it's continuous. So earlier, or in the first video more appropriately, we had this plot here. Here again, the standard scale color continues. This is what we have originally. So the appropriate scale function for color is in this case only that part here. But what we can also do is that we, instead of using this scale to map the color to the variable, is we can use a gradient. So because we have a color bar here, we can simply change, okay, you know what, the colors that are associated with low values shouldn't be dark or black. This like dark blue, I think is what it is. It should be, I don't know, low life expectancies is not good, so it should be something like red. So let's make it orange red too. This didn't come out of up in my head just now. Obviously, I'm taking this from the lecture notes, but you can take whatever color you desire. Point is, you can change the low and high values to the color you like. So when I was writing the lecture notes, I was looking at the colors you were given on the last exercise sheet. So in the exercises of the previous chapter, and I just picked orange red 2 and sea green 3. And what this does is changing the association with high values to green and low values of life expectancy to red. And that's more or less everything I want to say to scales and everything I want to say to plot customization. So yeah, this concludes our lecture. Again, if you want to learn more about plot customization, I can very strongly recommend this book. It's also from the makers of the ggplot package. So it's basically first-hand knowledge. Okay, so if you have any questions, then I mean, after you watch the video, you can simply write me an email. And if I don't hear from you, we'll see each other in the next lecture. All right, bye.